So one of the ways that we can think about acids is by its dissociation. It's dissociation, which is a fancy word for how it breaks up or pops apart when it's dissolved in water. So thinking about the example of hydrochloric acid. So we can have hydrogen bonded to chlorine. When this guy gets dissolved in water, some cool things happen. It dissociates. It actually breaks apart. But what's kind of cool is hydrogen leaves its electron with chlorine. So chlorine has an extra electron. That makes it a negatively charged ion. That's an anion. I don't know why my drawing tablet is making these weird lines. I am so sorry. But hydrogen, because it lost that electron, it now has a positive charge. And these positively charged ions, hydrogen ions, this is what makes an acid an acid. So that is a very important characteristic of acids, these hydrogen ions that are formed when acid dissolves in water. So H plus is formed when acids dissociate. We can also think about that H plus as being a proton. So we know that hydrogen has just that one proton and he's got that one electron. What happens when he loses this electron is all we have left is that proton. And so we can think of H plus as hydrogen ions as also being protons, because that's really all it is. So we can also think about acids as being proton donors, because acids like HCl pop apart to donate to the world these hydrogen ions or protons. We can think about acids as being proton donors. What's kind of cool, in water, that H plus, that proton sticks to a water molecule, and we form this thing called H3O plus or hydronium. So you can imagine that I have a water molecule here. We know that the oxygen side of water has two non-bonding pairs of electrons, the positive H plus and the negative electrons here are attracted to each other, and then they just stick together like little magnets. So we go from H2O to H3O, but because that hydrogen ion was positively charged, it brings its charge with it. This is called hydronium. H3O plus is called hydronium. In a couple slides, we're going to look at pH. pH is related to the concentration. We use these brackets to show a shortcut for molarity or concentration. So the molarity or the concentration of the hydronium ion in a solution is how we figure out its pH. Related to that, very similar but different, is the dissociation of bases. So bases will also dissociate or break up. They will often, not always, acids always make that H plus. Bases, many times, but not all the times, will dissociate or break apart to make a hydroxide polyatomic ion and then some cation. For example, if we're looking at sodium hydroxide, NaOH is a really strong base that we use in drain cleaners. Like, this is how powerful it is. But NaOH, when it dissolves in water, what happens is the OH part will pop off of the Na, stealing its electron, which gives it that negative charge. And that sodium, because it lost an electron, now has a positive charge, and these guys will float around in the solution separately. So we end up with some kind of cation, like that sodium, and then that OH minus, which is called hydroxide. Hydroxide. What is kind of amazing is that these hydroxide polyatomic ions in the environment float around until they find an H plus, and then they consume that H plus. Imagine that I have an OH minus and I have an H plus. Of course, these opposite charges are going to attract each other. But then when these guys bond, I have two H's and an O. Two H's and an O makes water. So because these OHs accept or consume these H pluses, we can call bases proton acceptors. So if a compound or a molecule takes up a proton, sticks a proton to it, it's considered a proton acceptor, and that makes it a base. Again, that OH minus ion is called hydroxide. And we can, just like with pH and the concentration or the molarity of the hydronium ion, we can figure out the molarity of the hydroxide ion, and we can use that to calculate pOH. pOH in chemistry is just as important as pH. We will use pH and pOH often. But of course, in everyday world outside of chemistry class, pOH is far less common. You have probably heard of pH. You may not have heard of pOH, but both are interesting and important, and we'll learn about them shortly.